Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by SatSearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello everybody and welcome to today's episode of the Space Industry Podcast by SatSearch. I'm joined today by an author called Christopher Prophet, and he is a SpaceX expert, if he doesn't mind me calling him that, and I want to discuss the phenomenon that is SpaceX in the modern space industry today with Chris. It'll be really interesting to go through how the company is developing and growing, as if we can have a little peek behind some of the sensational, often headlines that we hear, and get some insights from Chris's work, studying and understanding the company, and then also relating these to the wider space industry. I think would be really interesting for our listeners today. Chris, thank you very much for being with us today. Now, to set the scene, I was going to ask you first if you could give our listeners a bit of an overview of your background and expertise in the space industry and your work, and particularly with regards to SpaceX.
Yes, certainly. I'm from an industry background, specifically electrical side. I've done pretty well everything, I think. Everything you could possibly manage. I've done sales, purchasing, I've done commissioning. I worked for a semiconductor fabrication company for some years, and that was interesting work, especially troubleshooting for them, technical author. But I think my passion's always been writing, so I gravitated towards that, but with a strong sort of engineering base. And so it was rather natural for me to write about SpaceX. I'll give you a little bit of background. I was typing away, getting towards the end section of a science fiction story I was writing, full length, and it was going rather well, and all the characters were developing fantastic. But I'm always doing research in the background, and SpaceX just became an increasingly interesting topic. And I realized everything I was writing about in my sci-fi story, they are trying to bring about in real life. So I should be really writing about them. And that's what I've done since. I've essentially written 3 books about them. Although the first book was more about Elon Musk, and it was a very sort of high level thing about how he can manage this transition to the multiplanetary civilization that he promotes. But second book is very beginner to medium difficulty, and the third book is medium to advanced, if anybody's interested. That's the one I'm serializing on Substack, which is SpaceX Evolution, if anybody's interested. So that's my background. I don't know if there's anything else you really need to know.
Okay, great. Thank you, Chris. That's fantastic. Obviously, we'll include some links to your Substack and your books in the episode show notes if people would like to understand more about your writing on the subject of SpaceX. But let's also get some of that onto the podcast today. Now, as our listeners will be well aware, will be very familiar with, SpaceX is a very vertically integrated business in the space industry, and it makes the vast majority of the technology in-house. What are your views on this operating model for SpaceX and for the space industry in general?
It's only part of the reason they're successful. I think you ask many people what they think is the reason for SpaceX's success, and they'll say it's Elon Musk's money, but realistically, that's like going to a saucier, a sauce chef, and saying your secret ingredient is water. Now, there's an awful lot more going on there, really. The secret sauce for SpaceX, yes, in part, it is the vertical integration, because a lot of the components are made for government and to an exacting standard, and they're very expensive and they're difficult to get, and it's even more difficult to get the specifications changed to suit your application. So it was something they're really forced to do. They couldn't iterate the product as fast as the manufacturers could supply it. And also, if they get a decent price from the supplier, they went Russian in other words, the price went right up to the moon. And then they said, well, it looks like we're going to be producing this ourselves. So yeah, vertical integration is an important component. It allows them to really move things along. That's not so good for the supply side, but the suppliers can learn a lot from that, because if you shorten your supply chain, the links in your supply chain, you've got a lot more control over that product. One other benefit of that vertical integration they have is that if something goes wrong, then they know how to fix it straight away because they have intimate knowledge of the component. I'll give you an example. During the early days of the Falcon 9 test launches, they had a problem with a turbo pump. This is for a NASA launch, and the NASA were really worried about this because, as most people know in the industry, the turbo pump is like the heart of the rocket engine. And if the heart's failing, then they've got problems. So in any case, the NASA guys went down to the launch site where they were working the issue and said, how long is it going to take? 1 month, 2 months, and 3? And they said, oh, no, you see that guy over there? He's the guy who designed it. And that guy over there is a guy who actually fitted it. So we'll have done a couple of days, no problem, just straight swap. They understand exactly what the problem is and exactly how to fix it, rather than pushing it, going to the next link in the supply chain and saying, what about this? We're not quite, and they say, well, we'll have to talk to our suppliers and see what they have to say about their components and so on and so forth. So that is a big advantage. If anybody can do that in the supply chain, then I would recommend it, because that gives you a certain control and strength. And of course, you're reducing your costs for components if you're producing it yourself, more than likely. There are cases where you can get very cheap components supplied through outside suppliers. In fact, SpaceX engineers that they're given a really limited amount of money, and a limited amount of time to come up with solutions to make these new products, new components. And quite often that sort of forces them to do the vertical integration thing and come up with something themselves, because that's the only way they can supply it cheap enough. But sometimes they're doing a Dragon capsule, the Crew capsule. They found a handle from the automotive industry. And they said, well, it only costs a few bucks. Why are we building it ourselves? They tested it, it stressed, it fine. So they put it in. So they do vertical integration, but they're always keeping their eye open for opportunities. If somebody can come to them with a suitable component at a reasonable price, they will definitely consider it, because they're open to all possibilities.
What do you know about the company's development architecture and the production approach at SpaceX?
I'll take it right from the first interview. When they get people in, say for an engineering position, they want to know about your personal projects. They want to know what you've been involved in, you've achieved personally, whether that's with your own project at home, or maybe you've been working at a team, a university, or another company. But they want to know your physical involvement, how you succeeded. Now, that's important because they're looking for ace engineers. This is engineers that they have two classification engineers. One is like an ace engineer, which sees a problem and then solves a problem using new components that will design and build themselves. And there's the other type of engineer, which they try to avoid, which is what they class as catalog engineers, where they see a problem, they go online and they'll thumb their way through all these catalogs and try and find a component they can jam in, and hopefully it will do the job. Whereas they know the guy who designs the component is going to be the one who's going to build something that's absolutely suited to their system and can be easily adapted or fixed later on. So that's what they're looking for. And it's the quality of staff, really, that is the foundation of the company. They like people to take charge of the work. They give them authority, basically, agency, if you will, over their work, especially technical staff. It's technical staff all the way up through every level of the management, although the management is very, very light. They call it a flat hierarchy. It's a company of engineers that is built for engineers, by engineers. They're basically given carte blanche to solve the technical problems however they like. They have a management structure, but they don't get consulted, really. They just see a problem, and if it's a big problem, they'll do an ad hoc team get together a bunch of guys and girls with various talents and get in there, solve the problem. Sometimes even you might have Elon Musk in this ad hoc team because he's chief technical officer, so he's a skilled engineer. And if he wants to get involved, then he's perfectly happy short-circuiting the whole management structure and just getting in there and getting his hands dirty, which is what leadership is all about. It's that physical contribution and showing people the way to work. And sometimes they'll sleep under the desk or sleeping bag or something like that, but they just keep plugging away. The architecture is it's very enabling for engineers, whereas in a lot of other companies, it's very restrictive to engineers, where they try and reduce the sort of work they might be doing, the attempts to iterate or improve the product. Whereas at SpaceX, it's the opposite. They're pushing them all the time. Every day is got to be better than yesterday. They've got to improve the work, improve the product, improve the outcomes for customers, which is, it's a bit of a shock for people like NASA, but normally rocket companies just make a product. As soon as they can get that rocket working, freeze it. Everything stops pretty well, because when it works, you don't want to mess with it. But SpaceX, no, they're always changing stuff around. And NASA got to like that now, because they get upgrades on things like their Dragon spacecraft for nothing. SpaceX just say, oh, by the way, we've improved the life support system. And they go, oh, okay, fine. Tested it? Oh, yeah, fine, no problems. You give them a little bit of a shock sometimes. There was one launch where within about a couple of hours of the launch, they detected a problem with the software. And so straight away, they threw piles of programmers on it, and they sorted out the problem, and then they put it on the Iron Maiden, which is like a test rig. It's all the Falcon 9 components on a test bench, and it ran through a couple of times, worked fine. So about half hour before the launch, they uploaded the software to the rocket, and it went off fine. Now, NASA found out about this, and they said normally if there's a software problem, again, it'll take maybe 3 months to sort it out when you get to the actual end software programmers, wherever they are. But no, SpaceX, because software is their forte, really. They saw the problem, they solved the problem, they tested it, uploaded, and the launch went as programmed.
Yeah, no, that's fantastic. Thank you. That's some really interesting insights. I think a lot of space companies, especially those with real ambitions to scale, are increasingly focusing on this engineer first working culture internally. And we have these conversations both on this podcast, but at scale with companies all over the world. And it's really a big change in operation, as you say, compared to a space agency. Although, as you also mentioned, they are learning from each other too. And you can see operations and functions and responsibilities of engineers changing inside agencies as well as in the private sector. Yeah, really fascinating to think about. Now, one of the other big things that characterize SpaceX is obviously the close relationship of Elon Musk's other companies, of Tesla and the Boring Company. Okay, in times past, how much and in what ways do you think these other companies play into or have an impact on SpaceX and vice versa?
Right. It's a big question you're asking there. 2001, Elon says he's found a new mission, which is he's going to make humanity a multi-planetary civilization. And ever since then, everything he's done is fed into that mission. Now, SpaceX is an obvious one. You need space transport, and they've diversified into satellites. Satellites are always going to be useful, whatever world you're on. They're intended to extend it to the moon and Mars, and they're probably going to have pretty hefty laser links to link everything up, and those satellites en route to relay the information. But that's just the space side. They're going to need a load of other equipment, quite diverse equipment supplied. Apparently, the Cybertruck they're going to use that on Mars, a pressurized version, of course. And they do solar panels as well now, Tez. I'm sure they're going to be very useful on Mars, as they've been locked out of nuclear reactor work. They wanted to build their own nuclear reactors, but the regulations just was a little bit too steep for SpaceX. Boring company, that's another one that was set up by an ex-SpaceX engineer called Steve Davis. They need to bore extract an awful lot of material on Mars and probably on the moon as well to get raw materials. And the ideal machine for the job is probably a boring machine, which is incidentally what he's also set up there. So there's a lot of interchange of personnel between these companies. Charles Koeman, he was product manager at Apple. He came to SpaceX in 2015, and now he's VP of materials engineering at both SpaceX and Tesla. And also his materials team, they also shared directly between the companies. There's a lot of swapping, substituting of staff. Apparently, if you have an identity badge for Tesla, you can get into SpaceX and vice versa. In fact, Elon got in a little bit of trouble with that because he borrowed Andrej Karpathy from OpenAI, the company that does ChatGPT, and sent him over to Tesla. And they didn't understand it's a new company with him, and everybody gets swapped around and changed depending on wherever they're needed. And no, they didn't like that. He is a very skilled software engineer. So there you go.
My next question is on the SpaceX's kind of dominance in the launch segment. This is a topic that we've discussed before on this podcast, that although the obvious benefits that this brings, the low cost to orbit and the reliability, the cadence of the launches, the accessibility, all of this sort of thing. But there are some people in the industry who I think justifiably believe that this over-reliance on one provider, it can cause issues, and maybe hasn't yet, but could conceivably cause issues. And it would be great that if we had a more dynamic and participatory market in it, but it's obviously driven by who is able to do it. This is a market after all. What are your thoughts on this topic of the launch?
There's a sort of Chinese proverb that says a reed must bend with the wind or it must break. At the moment, I really can't see how anybody can seriously compete with SpaceX. Every day they're getting better, and they're actually getting better at getting better, because they have these systems where they don't have a system. They just strip out bureaucracy, strip out anything that's an impediment to development. They already have a large technical advantage with just having boosters reusable. When they go full reuse on Starship, then it's going to get really tough. However, there is some bright spots on the horizon for anybody who wants to compete with them in the launch market. That's made a bit of a rod for their own back there. But Elon Musk wants to transition to Starship. Now, Starship is a monstrous launch vehicle. It's Mars capable, can put 200 tons into orbit. But they're going to have problems getting out of using Falcon 9, because NASA and the military like to see continuance. They like to see they don't like to be messed around with the launch vehicles swapping in and out. So they have to maintain Falcon 9 for government work at the moment, and that's going to continue for quite some time. But they'll probably want to put as much payload as possible onto Starship to validate its use, give them a chance to practice launches, landings, because it's fully reusable Starship. That's the end goal. And the way they're going to achieve that is by doing lots and lots of launches. And they're going to need to do about 100 before NASA will agree to put their astronauts on it, at least for launching, I believe. But that does provide an opportunity. If Falcon 9 is not there, then there might be an opportunity for somebody to get in there into some of these niche markets for governments, particularly, to do more launches in place of the Falcon 9. But they might not want to wait for that one launch a year, which Starship does, where it can put everything in space on one one launch. There are opportunities, but going head-to-head with SpaceX, I wouldn't recommend it. I'd go round them, but don't go straight up against them. That would be my recommendation.
Okay, thank you. And how do you see, you mentioned Starship and some of the facts and figures there, but how do you see the next few years playing out with Starship and SpaceX's work in general?
I think Starship is a wonderful addition to the space industry, specifically the space exploration and the approaching space economy. There's been problems in the past. There's been a big dispute. Should we go to Mars first? Should we go to the moon? Should we send robotic landers? Should we send people? But with Starship, all of that just evaporates, because if they can make it fully reusable, which they have certainly got a very good chance of achieving, in my opinion, given their engineering prowess, that means you can go to the moon and you can go to Mars at the same time, with less budget, maybe an order of magnitude less budget. Do you send people or robots? No, you send them both, and their abilities complement one another. So it's useful to have drones operating alongside people. That is just a marvelous addition. Of course, what it's going to do for the space economy, the space economy is as open as people's imagination. If they want to put a Von Braun rotating space station in Earth orbit or the Lagrange points, SpaceX will do them a very good deal, I'm sure, for multiple launches. I was hearing about a guy called Saul Perlmutter, who's approached SpaceX to launch a space telescope, but he wants to actually change the whole of the upper stage of the Starship into a 8-meter telescope. So it's just whatever you can imagine doing with 200 tons of payload with an 8-meter fairing. So I'm sure there's an awful lot of possibilities there. That's where that's what I'm saying about bending with the wind. You should really be taking advantage of this opportunities to go to low Earth orbit or beyond it's unprecedented. And what's most unprecedented is the price. If you can go there cheaply, you can do pretty well anything you like. And that's where the space economy is really going to bloom. It's going to start in Leo, and then it will extend to Cisluna, and where it goes from there, anybody can say, but I'm saying Mars, I think, is my opinion.
Would you stick your neck out and give some dates when you think Starship will fly, Starship will get to Mars, etc.?
Okay, yes, I can say something about that. 2026 is looking very likely for the Artemis landings on the moon. Now, Elon Musk is, as I say, his life mission is to make us multiplanetary, and the moon is not a planet. All the work that's being done for the Artemis program, NASA has asked them to build a lunar lander based on Starship. All that is dual utility. It can be used either for Mars or the moon, because it's the same delta V to reach either. Comparable. It's comparable. So if they can land, if they do a test landing on the moon in, say, 2025, 2026, I would expect them to be sending a test vehicle to Mars off their own resources. Sure, in the next, let's just see, it's 2024, so around 2026 maybe, attempt a test landing just with an automated vehicle, and then the next one after that will be 2028, I believe. Yeah, that's when they'll want to try and do humans, but this is all optimistic if everything goes right. Because if they could send people to the moon, they can send people to Mars, and I don't think Elon Musk is going to be derailed by the fact that NASA would much prefer him to focus on the moon at the moment. Certainly, they're putting loads of work in place, like they're developing their own spacesuits for in-space maintenance, and it's a short step from that to a surface suit for Mars. And they're developing 6 launch pads that I know of. 2 of them are tentative. There's going to be sea-based pads, and they only technically need 1 to do moon launches with the human landing sister. system for the Artemis program because it's only launching once every 2 years. So what are the other 5 launch pads for? You only need them if you're really going to Mars in a big way.
Okay, great. Thank you. Thanks for being willing to put some dates on it. We've covered a lot of stuff about SpaceX today and about some of the with applicability to the wider space industry in general. Thank you very much for sharing your knowledge and your insights with us here, Chris. And just a final question to wrap up. I ask a version of this to all of our guests, well, most of our guests. What are you, aside from the things that we've covered, what are you most excited about in the space industry in the next 5 to 10 years, say?
Okay. What am I most excited about in the space industry? As a SpaceX writer, I would say what they're doing with Starship, it's just astounding. It opens your mind, really, to what's possible. It's a marvelous invention. If they can pull it off, it's the start of everything. Elon was actually talking about a much larger version of Starship being used for interstellar work, but I think they want to concentrate on getting to the moon and Mars first. If they get to Mars, well, they have a good starting place for doing interstellar, because a lot of the technology they're using, like fission, fusion, antimatter, you don't really want to be testing that anywhere near Earth. You want it somewhere remote. It's boundless. It's really, SpaceX is a gift to NASA. They're allowing NASA to do everything they ever dreamed of, and it's only going to get better from here out. And it's the same for satellite operators. Once there's one mega constellation like Starlink, many more will follow. And that's just pure opportunity for anybody who's building satellites or building components for them. Everybody, once one person's got a mega constellation, everybody's going to want to have one. They're just so blooming useful. I put a little article about Starship, which is the US government's. It's an NRO project, I believe, for building sort of a military version of Starlink. And it's a must-have technology. They can't ignore the opportunity, and there's plenty of money there from the government. Oh, by the way, Starship just uses anybody's sensors. It's a plug-and-play sort of bus. So, yeah, they use, I think L3 Harris put some in there, but if you can convince the government that they should have your sensor on board, I'm sure they will certainly take it under advisement.
Fantastic. Thank you, Chris. That's a good place to wrap up. I think, really appreciate the information you've shared with everybody today, and all the listeners out there, whether you're intending to get into the space industry, you're looking at opportunities in the space industry, or whether you are a fully fledged space engineer or one of the suppliers, someone on the end user side, or you're a user of satellite data, perhaps. The impact of SpaceX is enormous in this sector, and the opportunities that could come from its successful development of technologies such as Starship for the future, it also could be a paradigm change in your work. So I think the information that Chris has shared, his writing and his book, is a really good place to start understanding this 1,000-pound gorilla in the sector. And would like to say thank you again, Chris, for spending time with us today on the Space Industry Podcast. Thanks for having me. It's an extremely enjoyable experience. Thank you, Chris. And thank you to all our listeners out there. And please stay tuned to the next edition of our podcast. And if you're enjoying the show, please do give us a rating and a review on your favourite podcast player of choice. Really helps nudge those algorithms along. Share this information about our fantastic industry with more people out there. Thank you very much. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.